Hello, Professor. Here is my tube head project. Here is the tube head. The tube head, which is a tightly sealed heavy metal housing that contains the X-ray tube that makes the dental X-ray. The tube head also has a metal housing which surrounds the X-ray tube and transformer, which protects and grounds voltage components that contain the X-ray tube that produces the X-ray. Also right here is the PID. The label is right here. The PID is a lead-lined object that aims and shapes the X-ray beam. Also, the X-ray beam access through this tube head and access through the opening here. Also, here's X-ray information label. Once we move inside, you can see right here, which is a label called insulation oil. This insulation oil surrounds the X-ray vacuum tube and transforms to prevent overheating. And then you move over here. There is a cathode. This is supposed to be a cathode. Here's the cathode label. The cathode supplies electrons needed to generate X-rays with negative charge. The components of this thing is the wire filament and myocup. Here's the filament circuit, which provides power to the tungsten filament and cathode. Here is the myelin cup, which focuses electrons into a narrow beam towards the tungsten target. Also, some important labels or things to know is the MA, which increases or decreases number of electrons passing through the tungsten filament. Also KVP, which increases or decreases speed/force of electrons sent from the cathode to the anode. Also right here is the anode label. The anode converts electrons into X-ray photons in positive charge. The components of this are wafer thin tungsten plates embedded in solid copper rod. The tungsten target serves as a focus spot to convert X-ray into photons, producing 2 times of X-rays. General radiation, which it's the breaking Bremsstrahlung, and another thing is the characteristics radiation. It also has a copper stem, which dissipates heat away from the tungsten target. Here is my copper stem, and right there you can see the tungsten target, which I was speaking about. Then moving on, you can see my step-down transformers, which is right here, and my step-up transformer. The step-up transformer increases voltages from incoming 110 to 220, or also 65,000 to 100,000 volts. It activates by exposure button. Once you press the button in the X-ray tube, this thing activates. It also accelerates electrons from a cathode to tungsten target on anode. Then moving to a step-down transformer. This step-down transformer decreases voltages from incoming 110 or to 220 to 3 to 5 volts used by filament circuit. The filament circuit activated when control panel power is turned on causes release of outer shell electron from tungsten atom in the filament. Then moving on, right in here you can see a little blue circle. This thing is called the lead kilometer, and it restricts the size of an X-ray beam. It's right in there. Then if you see right here, that right there, aluminum disc. This aluminum disc filters out non-penetrating longer wavelengths of the X-ray. Then moving on to the outside, you can see this saran wrap. This saran wrap is the tube head seal, and it permits X-rays to exit the tube head seal in the oil filter's X-ray beam. It says it right here. permits X-ray to exit the tube head. Then moving on, you can see right here my plastic tube, which contains the copper stem, like explained before, and the myelopin cup. The X-ray vacuum tube is a leaded glass tube that contains the cathode and the anode, the heart of the X-ray generation system. And then moving on from this, you can see the filament circuit, like explained before, and then it moves to the myelopin cup, which produces an electron cloud, which moves to the copper stem. Then there's also a Brilliman window, which is a small number of X-rays that exit the vacuum tube through the unleaded glass window, and it goes with some beam of X-ray photons, and it goes through the PID, then it comes out the tube head.